Okay, this is the last thing that we really need to go over for your test. That is, I think there are two questions on the test where they ask you to identify what the y-intercept would be if you're given a particular quadratic function. So in the first one, it's pretty easy. It says if you graph this expression here, y equals 3x squared plus 5x minus 9, the y-intercept would be where? So this is in standard form. I know that it's in standard form because it's in descending order according to the exponents on the variables. And I don't see any parentheses, so I know it's standard form. And I know that when something's in standard form, I can find the a, the b, and the c value. And I know that the c value is always the y-intercept. So this one's pretty easy to find the y-intercept on. I would just simply choose the letter A, B, C, or D that had a negative 9 at it, because that's where my y-intercept is. Whatever the c is, the y-intercept is. If you look at this second one here, it's actually a little bit more complicated. It says if you graph 4x squared minus 8x equals 10 minus 2y, then the y-intercept is where? Well, the first thing I notice is that it's not in standard form, nor is it in vertex form. I don't see any parentheses. So that means that getting this into standard form is probably what I should do. When something's in standard form, I know that the variables go in descending order until there's a constant on the end, just like this. And I also know that the y value has to be by itself, like this. So I'm going to have to do a couple of things. The first thing I'm going to do is I'm going to get this c value, or the constant, the number that doesn't have a variable with it. I'm going to get that over to this side so that this looks like it's in standard form. To do that, I would just subtract 10 from each side. This is actually not a new skill to you. You're just manipulating the terms until they are exactly in the order that you want. So all I did was move that constant from the right-hand side of the equation to the left by subtracting it, because I know that a positive and a negative cancel out. And I know that I'm not going to put this with any of I can't add it to this or to this. It's its own term. So I have 4x squared minus 8x minus 10. It looks closer to this now. The one difference is that although it's in standard form, the y is not quite by itself yet because that negative 2 is attached to it in front. To separate a coefficient from the variable, I know that right now this really says negative 2 times y. So to undo this or get this y alone, I'm going to do the opposite of multiplying by negative 2, which would be to divide by negative 2. What I also know is that this is an equation, so if I divide by 2 on the right-hand side of the equation, I need to also divide by 2 on the left-hand side. And when I divide by this negative 2 on the left-hand side, each and every term has to be divided by negative 2. That makes this term right here, 4 divided by negative 2 is negative 2, and of course the x squared is still there. This term would be a negative divided by a negative, which will give me a positive. And 8 divided by 2 is 4, and I know that that x is still there. And then that last term, 10 divided by negative 2, or negative 10 divided by negative 2, and negative divided by negative gives me a positive, and 10 divided by 2 is 5. And now negative 2 divided by negative 2 cancels out, it's a 1, and the y is alone. It doesn't matter that the y is on the right side instead of the left. It's the same thing. The y is still alone. This is still in standard form. It goes x squared, x, and then the constant. So I can really easily see a, I can see b, and I can see my c value. And I know that the c value is always the y-intercept. So in this case, the y-intercept is 5. So even though I had to do a little bit of work, it wasn't hard. It's just the c value, and I just manipulated things until I got the y by itself and got the other side in standard form. Okay, watch this a couple times if you need to. See you, kids.